when we want to differentiate a function like x cubed plus sine of x, we know what the derivative of x cubed is. We know what the derivative of sine of x is. That is cos of x, and for x cubed that will be 3x squared. And it is only intuitive to write the derivative of this function as 3x squared plus cos of x, and that is right. However, to get more of a mathematical proof that we can write that the derivative of the sum is the sum of the derivatives, we need to look at the proof. And the purpose of this video will be to cover the proof of the sum rule and the difference rule and the product rule and the quotient rule. So let's get started with the first one. So the only definition I'll use throughout these proofs is the basic definition of the derivative, and that is that the derivative of a function, let's say u of x, differentiated with respect to x, is equal to the limit as h, a really small increment over x, approaches 0 of u, not f, u of x plus h minus u of x, all of this divided by h. And through this we can derive all the formulae. So if you wanted to sum two functions, so f of x plus g of x, you can write this same expression. So let's just rewrite it. So this will be limit as h goes to 0 of f of x plus h plus g of x plus h. I'm just putting in x plus h instead of x. And then minus the function itself, so f of x plus g of x. All this is being divided by h. Now, we need to think a bit on the side that we need to get individual derivatives. So we want this to be expressed in terms of the derivatives of f and the derivative of g. Now, to resolve this fraction, let's try putting all the f terms together, so f of x plus h and f of x, and the g terms, so g of x and g of x plus h. This would then give you limit as h goes to 0 of f of x plus h minus f of x, all of this divided by h. And this plus, I'm just putting it in the brackets, this plus g of x plus h minus g of x, all of this divided by h. And we know that the limit of two things summed together is equal to the sum of the individual limits. So we can write this as limit as h goes to 0 of f of x plus h minus f of x divided by h, plus the limit as h tends to 0 of g of x plus h minus g of x divided by h. And notice that this entire thing is the derivative of f with respect to x. So this is equal to d of f over d of x. And similarly, this entire thing is nothing but the derivative of g with respect to x. And there you have it. The derivative of the sum of the functions is equal to the sum of the individual derivatives. Let me just put in an x out there, and we're done with that. Now, instead of this, if you had a negative sign, if you wanted to figure out, let's say, d of x minus d of fx minus d of gx over dx, so the difference rule in differentiating functions, you can take this as an exercise. However, it's not really different. Instead of having pluses here, you would have minus, and you would again have a minus here. This would indeed turn out to be a minus, and you will get a minus again. Let's leave it as an exercise.